Hey folks, welcome, and welcome out there. We're so glad you've tuned in on this Friday, another day of specialized segments coming your way. I'm Ernie Roberts, I'm your host for this afternoon's segment, but you know what? A little different on these days. We actually get some paper, get some pencil. We're going to do some problems together. We're going to work them out. And I don't think you're going to need a calculator today, but I think you will be good to go with some good old problem segments here. And we're going to be dealing with some great things about inequalities. And it's another special day today. Folks, let's see what we've got on our slate here today, all right? Yes, and this is Veterans Day. This is November the 11th, and we want to say thank you to our veterans today for those who serve our country, keep us safe, secure, and preserve our freedoms also. So thank you very much to our veterans today. And we're going to go ahead and celebrate Veterans Day by doing inequalities, all right? Some of you are going, what? Well, it's a math class. It's a math show, okay? Math class, whatever you want to call it. Let's have some good fun with those two today, all right? No calls today, but you sure can check us still out on Facebook and send us email. But let's get to our first problem, all right? Here we go. And it's going to be a little bit of a rerun, a regroup, review, all those good things here for just the first couple of minutes. And then we're going to move forward with this. Remember last week we were talking about the words and then also the word or, little conjunctions that connect. And we're going to look at an and situation here. What it says is to graph x greater than or equal to -2 and x less than 3. Now, last week we were putting 3 lines and working it together, all right? What I want us to do is just simply take and think of numbers that are greater than or equal to -2 at the same time that are less than or equal to 3. So that would be numbers like 0, -1 will work. Actually, -2 will work, all right, because it's an equals to situation here. How about on the upper end? How about it? 2 and 3. Now, I hit those because those are where we go usually the first thoughts, integers. But there are also a lot of fractions and all sorts of other things, decimals, all sorts of great things that are between those numbers. So what we're going to do, we're going to spot -2 on that number line. We're going to spot 3 up here. And we're going to put closed circles there because whatever happens there happens, all right? We've got to use -2 and we've got to use 3 as closed circles. Now the question is, where do we just say some numbers? I talked about -1, that works, 0, 1 and 2, and little fractions and decimals that might go along with those. All those are between here. So here we go. We are going to be looking for these numbers that are somewhere basically between -2 and 3, and we include -2 and 3, call them inclusive. That's your solution. Now, I put this second little point right here. Take a look at this. You realize that's describing this solution. X is somewhere between what? -2 and 3, and we've got the equals to say they're included. So our graph here is the same thing. It's going to be the same thing. It's just another way to write the and result, okay? Didn't say the end, I said the and result. Sounds like end, doesn't it? But we're going to close those circles once again. And we will put a little shading right in between there because that's telling me where that x value is. So again, these are the same problem, the same situation, same graph, all right? So there's your start. We're not going to finish with that, but there's our start. Now what we want to do though is stretch that a little bit more, all right, and start having to work a little bit for our x's. We know what to do when we're going to graph them, all right, and that's the big thing in the end. But first of all, let's see if we can go back to get out the solution, all right? So it says solve and graph. We have our number line ready to rock and roll here. And I'm going to bring our little equation, our inequality actually here, even though it doesn't have any equals, does it? So it's definitely a total inequality. We got 2k, and we have it less than 6, all right? Now basically this is telling me this quantity of 2 times k is somewhere between -4 and 6. That's nice. But what I want to know about is where's k? What is k going to do? So I notice right here in the center I need to remove that 2. It's hooked in by multiplication. So I'm going to divide through by 2. Now if I do it here, folks, I got to catch up with the -4 over there. By the way, don't want to change signs on that. It's just going to be dividing by 2. Over here, we're going to also divide by 2. So in other words, we did everything up and down the line there in all 3 places. You say, well, Ernie, what does that do for us? Well, that brings us to -2, brings us to k in the middle, and 3 on the outer end. My goodness, that almost sounds like the last problem we did, didn't it? It almost looks like it. There's one difference. We don't have equals. All right? So let's look at how this is going to wrap up. We're going to put a -2. We're going to put our 3 right there. And you know, my friends, we're going to open those circles this time, and it's still telling us K is between them. So we're going to shade in between. So there's your fine line of difference. It's still an and, by the way. It's still an and situation. You're basically saying that K is greater than -2, and at the same time it is less than 3, but we don't include those. It's not an equals to situation here, all right? So there you go. Fine line of difference. Very subtle, but very important. Open circle, closed circle. You guys know what to do, right? You all know what to do on that. If it's got an equals to, close the circle. If it's got just less than or greater than, leave it open. Leave it open when you shade, all right? Now, let's take a look at our next little problem here. It's kind of stretching out again. It's another and situation because our variable is going to be right there in the middle. So let's pick it up here. I'm going to move it down here just a little bit, shift it down. How about it? 5 less than or equal to y minus 8. This will allow you all to get them written down at home. Remember I said, get those pencils and papers. Yeah, so you can take along with it here. What's keeping me from having y by itself this time? I have a -8 that's staring at me, say, let's move, we need to move. So let's do it. Let's add 8, because that's how we get rid of a -8. Now let's remember, we're going to add 8 over here. We're going to add 8 over there. All right, so adding all these points together, let's see what happens. I have 13 to the left. Wow, I have this less than or equal to y in the middle. And over here, it looks like we're jumping all the way up to 23. Now keep in mind, we want y by itself in the middle. We've got it. So at this point, we're ready to go to our number line and say, hey, let's illustrate. Let's see what this solution looks like, all right? So again, I'm going to use the numbers 13. By the way, they're all positive. So again, you know, sometimes we tend to think, Ernie, why aren't you putting it in the middle with the 0? That's okay. That's okay. Number lines usually do go that way, but we're just going to focus on what we have here. Since they're rather large numbers, I really didn't want to extend too far to the right, okay? So close circles. Why? Because there's equals. And there's a y. Yeah, that's true. And let's fill it in the middle, because we're basically saying y is between that 13 and 23. Everybody see that? So we shade in between 13, 23. And that means all these numbers, all these integers, fractions, decimals, rational, irrational numbers even, all right, that fall between 13 and 23 are all waiting for us right there. So there's your solution. And again, that's what we're doing today. We're going to be solving and graphing, Sometimes the word and will appear, sometimes it won't, and then that pesky little word or also could appear. So let's take a look at our next one here. It says solve and graph, and yes, there it is, that and. Now this and up here just says we're going to do 2 things. All right, we're going to solve it and graph it. But this is important. It's between our 2 inequalities here. So we're looking for basically where do these pieces overlap, all right? And by the way, that's a little negative right there. So let's work down the line here. Start off, go ahead and copy this one down, my friends. We've got 3x minus 9 less than 0. That means this value over here has got to stay negative when we put a value of x in it. All right, that's the idea. So let's see, we're going to add 9. You say, well, that sounds easy, and it is. We're going to add 9, and we're going to have 3x less than 9. And that tells me right over here that x is going to be less than 3. All right, that's the first thing that's important. All right, I'm going to draw a little line right down here, all right, just to separate these things. Over here we got negative 2x plus 4 less than 8. Let's not get too excited, but I see a negative 2, and some of you are going like, oh, we got to look out for that, don't we? We really do. We have to watch out when we deal with a negative, right? When we divide or multiply by a negative. However, first we need to deal with our 4, and that's what we're going to subtract 4. And by the way, subtracting 4 on both sides does not affect this less than. It's still fine and dandy, all right? So let's see where that's going to take us. It's going to take us to a negative 2x. We got that less than rocking for us. And over here we've got a 4. It is positive 4 because that's what 8 minus 4 gives you, all right? And also the positive obviously is bigger. Now, about to watch out here. We're going to divide through by negative 2. And what's going to happen is we're going to get x, and we're going to get a negative 2 on this side. But you see what's going on? Oh, I hope everybody does. Greater than. All right? So, down here below, I'm running out a little bit of room here, but down here below, what does this tell me? It sounds like I keep getting the same answer for every problem we're doing today, it looks like almost. Only one so far has not had the -2 and a 3. One of those great moments. All right, folks, but let's see what happens on this. We always love 3 here at Mathline, right? My director friends and all that. So we love the 3s. The -2 has gotten its own little character today, all right? But let's find those things on the graph. There's -2, and there's your +3 up there. And this time, notice they're open circles because we are not putting an equals to tacked onto it, all right? But if you'll notice, once again, we're going to shade in between because this is saying where do these answers both occur? I'm looking for answers that are smaller than 3, but bigger than -2. So again, there they go. Some of you are going like, man, if you take a test in his class, the answer is always the same, isn't it? Not always. It's just happened to work out the way on these. Hopefully, I promise and say that they'll change as we move up the ladder, okay? A little bit different. These were not intentional to come out like this. My goodness. Let's take a look at our next problem, all right? And I hope y'all enjoy it while we're working through this thing. Director says I need to put a 3 down here. We're going to see. I think we may get away from that 3 tradition here. We'll find out. We'll find out. And I may eat those words. Let's see. Starting off right off the bat here, we've got an OR situation. You said, what's the difference of that? That means we can keep these solutions and these solutions. We're not looking for overlapping. We're just going to use everything. Everything that works, okay? It can work for this one or it can work for this one. We find out numbers for X, all right? So let's take a look. Let's look at the left-hand side here, all right? Go ahead and recopy that one down at home. And we've got greater than 7 there. And I'm going to just go ahead and draw my little line down the middle here. And we've got 4x minus 6 less than your -10 over there. So we're going to watch our signs. We're going to watch everything going on here, all right? We want to make sure everything works right. No worrying about switching the inequality, do we, this time, folks? Nope, I don't see any need to worry about because we've got +5x here. We've got +4x here. Life is good, all right? But what we do need to do is get the x by itself. So let's take care of that. Let's add 3, first of all. We're going to add 3. Right there it goes. C by 3 goes as a positive on the other side. Now we got 5x less than, looks like 10. And folks, when we divide 5 into 10, we're not worrying about sign change. So we're just going to go ahead and say that's going to give us x greater than 2. Looks like we got away from the 3, and we got away from the -2 there, all right? So a little different answer there. Now, let's add 6 over here, see what happens. Add 6 there. And that's going to give me, looks like 4x less than, it looks like -4, folks, because that -10 is bigger than +6 in terms of its absolute value. So we're going to go with the negative sign there. And we're going to divide, and that's going to give us x less than -1. Now, keep in mind, on this problem, we are not concerned with where does it overlap. Because obviously, there are no numbers that are greater than 2 at the same time being less than -1. If that had been an and, we'd have no values. We'd have no solution, all right? But the key word, the big word is that we have or. So we can use any of these numbers. We're good. We can use any of those numbers. We're good. Let's make them work. All right, so on the graph, here we go. We're going to have, and by the way, everybody, this is +2, this is -1. Be sure the -1 winds up on the correct side of your graph when you're placing the 2 along with it, okay? It is going to be in that respect because -1 is to the left of the 2. Now, what are we going to do? I don't see equals to on either one of them. So we're going to put open circles right there. And according to this side, it says x is greater than 2. So out here from the 2, we're going to shade right on out there. And we're going to darken that a little bit. And notice everything else so far has been in between. All of a sudden, we're going to the right. And we're going off the page, so to speak. All right? The values, because we're looking for numbers that are bigger than 2, and we get to use all of them. So that means 2, 3, 2.5, 2 3/4. Every fraction, every decimal, every irrational number from here to +infinity. Whoa, that's great. Now, let's take a look at our other side here. It says x less than -1. Got it? So we are at -1. So less than says, let's go left. And here's what happens. We get a hole in the middle, it looks like. Because those are the numbers that aren't going to work in either one. All right, remember what I said? If we were looking for the and, we would have had no solution because there is no overlap between these. But since we are looking for less than -1, haha, there you go. Greater than 2, haha, there you go. And that, folks, gives us a nice picture of what values will work. What values work? Infinitely many. I mean, you can come up with, you can keep going and going and going. Easy checking though. But remember, all it has to do is satisfy one of these at a time. So that's why we say good to go, and problem done, okay? Problem ready to go. And you solved it, you graphed it, and you've got a great picture there. Let's take a look at our next one here, all right? Another or situation. Got to be careful with these. They're again, watch the signs. I see some negatives popping up. Y'all see these negatives? There's one, and oh, there's a minus x. That could be interesting too. So let's just take these problems one at a time. I have a minus 2x, or a negative 2x, as we love to call it, minus your 3, and we're going to say that's greater than 5. I'm going to draw a line right down the center here, and we're going to go ahead and write our 3 minus x greater than 5, all right? And again, folks, these parts could get stretched out to all over the place, but the process is still the same. You're going to get x by itself, and you want to make sure that you can graph what you have for your final answer, and you want to watch out for these negative signs here when we have to divide in a minute. Let's go through one thing at a time. How about it? Let's add 3 both sides here. And I'm seeing negative 2x greater than 8. And again, we're going to divide by negative 2. So my friends, it's got to shift. That inequality has got to shift. So we're going to be taking up x. We're going to come up negative 4, but we've got to make sure that greater than becomes less than. That happens when we divide by negative. And when we subtract things, no problem for both sides. But when we divide, this division property of inequality, we call it, signs will shift, all right, as will the inequality, all right? So signs change, inequality shifts. You got to make sure you cover all those bases, all right? Let's see what happens on our next one here. We're going to subtract 3, and I am seeing, hope you all are seeing too, I'm seeing looks like a minus x. Be sure you keep that in there. That becomes like a negative x, or the opposite of x, as we like to say. And over here we've got greater than 2, all right? Because 5 minus 3, it's going to give us 2, all right? So everything looks like it could be positive, except we got to divide by a what? Negative 1. So when we divide by negative 1, folks, we get an x, we get a negative 2, and we also, did we get a shift? We got a shift. Okay, it's going to the left also. So you say, well, Ernie, what do we do? What do we do? Well, let's put these things on the number line. Let's see, negative 4, right there you go. How about negative 2 right there? And we can move on over as far as we want to go to the right. But you know what? We're all about less thans here. Both of these are about less thans, all right? So here we go. Open circle at negative 4. Shade to the left, less than, okay? Open circle at negative 2, shade to the left. Now, folks, what do you notice? We just barreled right through negative 4. So it's now part of the solution. Why? Because it works here. May not have worked here, but it did here. So again, with the or, you just basically glue them together. And the final solution on this one, by the way, is just simply x less than negative 2. That would be how you describe that graph. Now, you say, Ernie, we didn't see that the last time. No. In fact, on the last one, guys, let me shift away from me just a second. Let's go back to this one. What was the situation here? Let's go back to this one here. And I'm going to be a little more elaborate. What would be our final solution here? Would be x less than negative 1 or x greater than 2. And that's the best we can do. We can't jam that together into a combined inequality, all right? We can only keep it separated with the or, because what's going on? You're not in between. You're going opposite ways here. It's an or situation, all right? So that's how we describe it when those graphs, as we like to say the word diverge, means they go separate ways, all right? That second one we just did just happened to wind up going all the same way. Let's go back to an and here. How about it? Let's see what we've got here. We've got, we've got 3x minus 7 greater than or equal to 5. And we have also 2x plus 6 less than 12. All right, let's get x by itself. Good news, we've got positive. By the way, the and tells me we're going to be looking for where do they overlap. Where do they overlap when we get to our x values at the end? So let's see what happens. First of all, we're going to add 7. I hope you all are working this along home with me here. Let's add 7 to both sides. We got 3x greater than or equal to 12. and now we're going to divide, and we're going to get x greater than or equal to 4. All right, that was easy. And over here, we're going to have minus 6. Minus 6, how about it? We're going to have, looks like 2x less than or equal to, is that 6? Well, minus 6, everybody got it? All right. And here we go. Oh, we're back to 3. That's nice. Less than or equal to 3. Now, here's what I'm seeing here. This is one of the situations, all right, if we were going to find on the number line, all right, we've got 4. Well, let's say that's 4 right there. Over here we got 3. And we're looking for numbers that are less than or equal to 3, greater than or equal to 4. Now, you said, Ernie, the last time you just put those graphs in, you said it was an OR. All right? So if I do this, notice what's happening here. We're shading to the left. Over here, we're going to close that circle and shade to the right. But remember what I said with an and, we're looking for where they overlap. Where do these two graphs overlap, folks? They have no overlap. There is no common ground here. So no overlap, no intersection equals no solution. And we'll slash it just like that, okay? That's the story. Now, let's go back and look at this just a second. First of all, when you get something like this, the first thing you always want to know is, did we do it right? Well, let's see. We added 7. That gave us 12. 3 into 12 goes 4. We don't need to shift. We're not shifting inequalities, are we? All right, because there's no negatives involved, so x greater than or equal to 4. There it is. All right, let's take a look at our second one here. Subtract the 6. We get 2x less than or equal to 6. And here we go. We're looking for numbers that are greater than or equal to 4 and less than or equal to 3. I can't think of any. You can't think of any. None of us can think any. So guess what? It's one of those situations. No solution. No solution. So not always are there numbers and answers waiting for it. We love to think there's always an answer. We love to think there's always going to be some situation there that's going to make this work. But doesn't always happen. Doesn't always happen. Hey, let's take a look at one more here. All right, we've got this one. It says solve and graph. Oh, I did everything wrong, didn't I? I put the 3x onto the right-hand side. Oh, here's one on the left-hand side. It means we got to think a little bit, all right? We're going to be fine. We're going to do that. And also we're saying 8 greater than. So go ahead and copy these down at home, folks. Let's get out of this. We'll work out of this thing. There's not a wrong way to write an inequality. We're just going to work it out right, okay? So what we're going to do, very first thing, we're going to go ahead and make this happen for us. We're going to take care of subtracting 5. And my goodness, that gives me 8 minus 5. Everybody got that one? It's 3. And we have this negative 3. So guess what we're going to do? And this is we got to be very careful. We're going to divide by this negative 3, which is going to give us a negative 1 on the left. Everybody good on that? And it's going to give us x on the right. But all of a sudden now has become less than in there. Now that's not x less than negative 1. That's 1 less than x, or excuse me, negative 1 less than x, which translates to x greater than negative 1. So we've got to remember that, okay? That's the story there. Now, let's take a look at our other situation here. What's going on over here? Well, it looks like we're going to have values. Going to have values here. What happens here? Let's see. We're going to subtract 5. And we're going to have negative 3x. And it looks like it's going to be greater than, what, negative 18. When we divide by negative 3, we're going to be picking up, what are we going to pick up here? We're going to divide by negative 3. We're going to end up with x less than 6. Now, according to this, we're saying if we find our negative 1 down here, we're saying that x is going to be greater than negative 1, okay? And we're also going to be saying that x is less than 6. That's a combination. It's an and, folks. It's an and. And that means we're looking for the overlap. So we're going to open those circles. And we're going to ask ourselves, what kind of numbers? Well, there'd be a 0. There could be a positive 1. You get the idea. It's anything between -1 and 6, including the fractions, the decimals, the rationals, the irrationals, all those great numbers. So here we go. Shading in between. And again, up here, we watch these signs. Be very careful, all right? You say, well, Ernie, they were facing the same direction starting out. But remember, we had the -3x on the right here, and on the left. This was like a double whammy switch, okay? And some of you are going to ask, could we have written 5 minus 3x less than 8 to begin with? Yes, we could have switched it right up here, gotten the x on the left, but the way we did it, it works. Oh, by the way, how about it? -1 less than x less than 6. There you go. Combined inequality. Hey, thank you for tuning in today. Veterans, we thank you. We celebrate you today on Veterans Day. We thank you for what you do to serve our country. Folks, we'll be back again on Monday live, having a good time with some great calls. See you then.